right, let's start our next section, which is 3.2. That's about basic differentiation and rates of change. So we're going to start with the constant rule, which says when you take the derivative of a constant function, you get 0. So if you think about a constant function, right, graph a constant function here, this makes sense because if I look at the slope of the tangent line, well, at any point it will just be a horizontal line. Slope of a horizontal line is 0. Another way I can write this constant rule is it says that the derivative, d dx, that means derivative, of a constant is 0. But let's see, why is this really true? Let's use the definition to see if we can verify that this is true. So here's my constant function. It's equal to c. And let's look at the derivative definition. The limit is delta x goes to 0. F of x plus delta x minus f of x over delta x. So here your function is always constant. It's always equal to c. And so in the numerator, you're getting c minus c over delta x. Well, c minus c, that's just 0. 0 over delta x. Or really just overall, I can just say 0 here. And the limit of 0 is 0. So let's look at some examples. So the first one, if my function is y equals 7, then the derivative of that, dy dx, that means derivative of y with respect to x, that would be 0, because it's just a constant function. If I'm looking at the function f of x equals 0, the derivative, f prime of x, would also be 0. Now the third one is y equals pi squared. Now this kind of question usually stumps people a little bit because you see a pi there. Pi is just a fixed number, right? When you square pi, it's still a fixed number. It's a constant. And so the derivative here would still be 0. There's no x's in that equation, so this function is constant. All right, so now let's talk about the power rule. The power rule, and I'm going to state it here, if n is a rational number, then the function x to the n is differentiable, and its derivative, d dx of x to the n, is n x to the n minus 1. So you bring, essentially what happens here is I bring the power down in front and then I reduce the power by 1. All right, so let's look at some of these examples. So I'm going to give you the function over here, and let's write the derivative over here. F of x would be x cubed. What would the derivative be? Well, remember, you take your power and you bring it down in front, 3x, and then reduce the power by 1, so it'll be 3x squared. It's the derivative. Let's look at the next function. G of x would be the cube root of x. Well, it might help you first if you rewrite your function as with an exponent. So let's rewrite this as x to the 1/3. And then g prime of x would be, what do? Take my power, 1/3, bring it down in front, and then it'll be 1/3 minus 1, or a negative 2/3. Negative 2/3. You can leave it like that if you want, or you could move it to the denominator and write it with a positive power, x to the 2/3. Let's do one more. Let's do number 3. Y equals 1 over x squared. Again, you might want to write this as x to the negative second. Bring it up to the x to the numerator. And now do the power rule. So bring the negative 2 down. Subtract 1, so it'll be negative 2x to the negative third. And again, you can leave it like that, or if I want a positive exponent, you got to move it to the denominator. Okay, and there's my derivative. So don't forget that you might need to rewrite your function in order to use this power rule here. And let's look at one more problem. Let's look at the following. I want you to find the slope of the graph of the function x to the 4th for each value of x, and there's going to be 3. I want x to be -1, b x equals 0, and c x equals 1. Okay, so we're going to take the derivative, and because I'm going to use the power rule here, it saves me a lot of work. I don't have to do the limit anymore and do my power rule. So bring your power down, 4x, and subtract 1, 4x cubed. That's my derivative. And now I can answer these by plugging in my value into my derivative. So if I plug in -1, you'll get -4. If I plug in 0, you'll get 0. And if I plug in 1, you'll get 4. Now, if you wanted to, you could verify that these answers make sense by looking at the graph of your function. So if I graphed y equals x to the 4th here, and I'm just going to try to roughly sketch this for you if I can. Looks like this, looks like that. If I look at the tangent line at -1, x equals -1, the slope, the line's going downwards, so the slope would be negative. Here at 0, the tangent line would be horizontal, the slope would be 0, and then here, my tangent line would be going upwards, the slope would be positive.